Alright guys, so we are back with another challenge. Now in this challenge we are going to add two numbers. So let's say for example we have 256 and we want to add it with 1024, right? So let's say we want to add these two numbers. But instead of like adding them normally like any other application, we want to construct linked lists based off of each number. So our first number would become 1024, and our second number would become 256, right? And we have two ways of constructing this linked list based off of each number. The first method, which I just wrote, is to construct these linked lists in forward order. Okay. And the second way to do this is to construct these linked lists in reverse order. So 4, 2, 0, 1, and 6, 5, 2. All right. So this would be our reverse order. And what we basically want to do is to find a way so that we are able to add these numbers based off of the linked lists, not just by doing basic math arithmetics. So if we think about how we do this in regular math, we are probably starting from the ones place in both numbers and then adding them up. And then whenever we have a digit that is larger than 10, equal to or greater than 10, we will carry its 1 to the next place. So we will carry its 1 to the next place. And we will again sum the numbers up and add it with the carry that we had from the previous addition that we just did. So it will give us 8, and let me write it down better. And we will add the remaining numbers just like that as well. So we can assume that the first time that we did the addition, we had a carry of 0, and the other times as well after we used that carry, we had a carry of 0. So we can assume that the carry is 0 unless we override it, unless we assign something else to it. All right. And the other thing is that if you notice that we are going from the ones place to the hundreds or thousands place, right? So maybe doing this with the reverse linked list would be easier for start. So let's go with the reverse linked list then. Let's try to do the same thing this time on our linked list. So the thing here is that we don't know for sure beforehand which number would be larger, right? This is the nature of linked lists, and we don't know how long each list is. So, and they might vary in size, which is okay in our reverse linked list, since the only thing that we have to concern ourselves with is that we have to make sure that the ones place of the two numbers align perfectly, which in this case they do align perfectly. So we can be sure that the two first nodes that we go through are our ones digit. All right. So let's see how we can do this. So one way to do this is to basically have a function which gets two nodes. so node 1 and node 2, or number 1 and number 2 for that matter, right? And inside this function, we will go grab the data of the first node, right? And go grab and read the data of the second node and sum them up. And maybe also have a carry here somewhere. Let me actually write these down with another color. Let's not use red for everything. Maybe this color. So we have a function that receives n1 and n2. And inside the body of this function, we were adding up the value for n1 with the value of n2, right? And we will also add these two values with the carry digit. So let's assign carry to 0. Let's do it somewhere around here. Right, carry is 0. And we will also add carry to this list as well. So we will sum these up, and we will call its result, how about just result, right? So this is the result of this addition. Then what we want to do is to go to the next node, or sorry, so the next step would be to check for the result and see whether it's greater than or equal to 10, just like the case here, okay? So what we want to do now is to branch out basically. So we will check to see whether result is greater than or equal to 10. And if it was greater than or equal to 10, what we will do is to basically, if the result was, so if it was greater than or equal to 10, we will assign result. So what we will do probably is to grab the result, and divide it by 10, right? And then grab its remainder. So if we had, 11, if we divide that by 10 and grab its remainder, it would give us 1, right? Let's actually go with 12. So if we divide that by 10 and grab its remainder, it would give us 2, right? So that would be the ones digit. So this would be the actual result that we want, right? And if we this time divide this by 10, so just do a normal division, and then floor the result, right? So it would become 1.2 something, or just 1.2. So we would want to floor the result. So always round to the lowest value, so 1 in this case. So that would give us the 10th digit, right? So then we would want to assign carry to be result divided by 10, and we will actually do the floor operation on this. All right, so this is how we will override the carry from there. And also let me point out something. So the result that we get here would become something like this in this situation, in the forward order, right? And it would have to look something like this in our reverse order, right? So the result itself is also a linked list. So for each of these, We want only the ones digit, right? So that's why we are grabbing the ones digit and storing it inside the result. And we would probably want to do this first and do this second, just so that we don't lose reference to the original result. But yeah, we will worry about that once we get into the code. And if the result is not greater than or equal to 10, then we would probably not want to do anything with it. We would probably keep it as it is. So after we're done with that, we have our result. We have our carry for the next to calculate the next node. Now we need to basically go to the next node, right? So we would want to do something like this. And into is into.next. Okay. Now, yeah, and this block here would be where we basically do the iteration, right? Here. And also after, like, if the result actually is not greater than or equal to 10, so else, the thing that we might probably want to do is to reset carry, since we already used the value from the previous iteration, its value from the previous iteration, so that's what we want to do, right? But there are some details here when we convert this into code, and that is that what is result instantiated as or initialized as? What is result? Result has to be a node, right? Has to be a linked list node. So maybe we'll have to say that also result is a linked list node, or a new linked list node, and it's called result, right? And maybe then we have to say, maybe then we'll also have to create a new node at the end of each iteration, right? So we'll have to say something like go to the next node, right? And then we will need to actually create that next node, because that next node doesn't exist here. It is pointing to null. It is considered as being a tail here, right? So, and we will only want to create a node once we know we want to store a data. So let's dive into the code and see how we can handle this. So for the big O complexity of this, I would say it's the O of the larger linked list. So if this is the, I don't know, longer linked list and this is the smaller linked list, so I would call it O of L. And this could also be the space complexity of the function as well. We might end up creating one node more than the longer node if there is enough carry from the previous additions. But yeah, you can almost say that for both the runtime complexity and space complexity, this function would perform at big O of the length of the longer linked list. All right. So with that, let's go to the code. All right, so we have our linked list here. So let's go with the example that we were just discussing on. So 256 with 1,024. Let's remove the reference to the node 8 and remove it altogether. Right? So if I print this now, this should give us our two linked lists. And we want to render them in reverse order, right? So let me just fix that. 4201 and 256. So let's take a look again. So here's our two linked lists. Now let's create a new function here. I'm going to make it a public function, public static function, and it will return us a linked list node. And let's call it sum reverse. And it will receive two linked list nodes. So I'm going to call them just n, both for number and node. And here we would want to create that linked list node for, let's actually not do that now. Or maybe, yeah, let's do that. Linked list node of result. And then let's return that result. And then let's, what is the issue here? Yeah, that's okay for now. And then let's create an integer for carry. Even though we don't need to make it an integer necessarily, we're doing it for the sake of simplicity because all of the data inside these nodes are integers. So I'm going to call it carry and set it to 0. And now, since we don't know the length of our linked lists beforehand, we will use while loop. And while the linked list 1 has not reached null, or while linked list 2 has not reached null, or while we have a carry, so carry is greater than 0, let's run this while loop. And what are we going to do inside this while loop? Well, at first, I personally want to create a new node here. New linked list node. And yeah. Let's do that. I'm not going to do that. Okay. Now what? Now I want to read the value of n1.data and add it with n2.data as well as carry. And store it somewhere and call it result. Oops, we have the same names here. Let's actually call that sum. And then I'm going to go inside this condition here. So I'm going to calculate the carry now. So if the sum was greater than or equal to 10, then what if the sum, first of all, was less than 10, right? Then don't do anything and just set carry to 0 if it's not already at 0. Else do these set of calculations. Go and set carry to sum here math.floor of sum divided by 10. So get the tens digit there. And since this returns a double, we have to cast it to type int. So let's do that. And we have our tens digit. Is that correct? Yeah. Now, let's change the sum if this condition was true. So grab the sum and grab the previous sum, divide it by 10 and get the remainder and assign it to sum again. Okay? Yeah. And then grab this resulted sum and put it inside our result node. Create a new node and put it there. Alright. Cool. Now, at the end of this while loop, we would want to go to the next node of result and go to the next node of n1 and go to the next node of n2. Cool. Alright, so there are a couple of issues here. So suppose that we are at this point here. We are adding 2 and 0, and then we want to go to the next nodes of these linked lists, right? We want to go to the next nodes and read their value. So what happens at that point is that the next node of, say, for example, n2 doesn't exist. So there is no n2.next, right? So this doesn't have any nexts. This can't go to the next node. So we have to do something for this there. And as well as we'll have to know when to read the data of a node here in case the node was null. Alright, so and also result.next doesn't exist as well. So we actually have to create that new node. If and only if one of these went to the next node. Okay, so what I would want to do is to create some if statements. So if n1 dot next was not null, right, then go to the next node of n1, and same for n2. So this is that. Good. Now So if n1.next is null, then we won't go to its next node. So if we are at this situation here, that the next node is null, we will stop here, right? Then we want to know whether there is a next node here. So what we'll have to do is to see whether is to figure out whether there is a new node somewhere. So we'll have to check for n1 and n2 here as well. n1, n2, and carry. Or we can just trust this. Yeah, just trust this and create that new node while we are iterating through the linked lists. So if we are here, then we'll do that. And then we'll probably don't want to go to the next node here. What we will want to do is to say if result is null itself, which in the first iteration it is, then do this. Else, assign the value to result.next node. So new. Yeah. Okay. And then do this. And so this time what happens is that we are inside this loop. If the result is null, which for the first run it is, it will create a new node in its place. And at the next iterations, this is the condition that evaluates to true. And only at these iterations, after we create the next node, we would want to go to the next node. So after doing this, I can say go to the next node, right? And now we have to start getting smarter here. So I can just start saying if n1 was not null, or sum should be 0, so sum is 0, int sum is 0. If n1 is not null, sum plus equals n1.data. Okay, that's good. If n2 is not null, then sum plus equals n2.data, and just add the carry to it as well. Maybe I can do it at the beginning. Sum plus equals carry. Good. All right, then we have a function here, and I think it should work. I don't see any problems with it. Other than this squiggly line, value result is always null. I don't think so. So what is this one? Um, let's give it a shot and see if it is really no always. Okay, so I just noticed another issue, and that is that we'll have to remember where the head of result linked list is. So I think it's fair to say if result is no, then it is the first node. So I would basically do this. I would create another linked list node called result head and set it to null as well, just to avoid any issues. And I will, at first run, assign result to that new variable, and then get the value of result head so that we have the head of our result linked list. So what is the issue here? So if result is initialized to null, what happens if I do this? Then this condition is never true. Result. Okay, so what happens if we add 2 zeros at the beginning? Like, what happens if our digits here are zeros, right? Because we are allowed to have zeros in our ones place. And if that case ever happens, our first node should return 0 by default. So, and when we create a new linked list node at the beginning, it automatically returns 0. So let's do that as the default value for result. Okay. Now I'm able to assign result head to result here, and I am able to get rid of this line to this, and then result is never no as far as I know. Okay, so how am I going to detect whether we are in our first iteration or not? So one thing that I might be able to do is to just get the value of n1 and n2 right away and create that first node and not worry about carry. And then, that's not good, since I'll probably have to get the value of carry somewhere else then. Like, I have to rewrite all these functions outside the while loop. So maybe I'll have to create that new node, and if I'll have to keep an integer somewhere to let me know if this is the first iteration or not. So maybe we can just create a byte somewhere, and then if divide is strictly equal to 0, I is strictly equal to 0, then assign result the data to sum, right? And then I plus plus, so that we don't run into this condition anymore, right? I can do that. And otherwise, just go with this flow over here. So will this now work? No? Why not? Oh, I'm not even calling my function, so my bad, sorry guys. So let's call our function actually. Sum reverse receives two nodes, node 1 and node 1 and node 4. And let's store the results somewhere like this. And since this is of type linked list node, let's print it out using our linked list nodes print method. So print the result here. Now let's call this. Okay, we are in an infinite loop. Congratulations. And why are we in an infinite loop? So let's say this node's next data. Okay. So we might want to get out of this loop. So I'm not actually going to use this condition anymore now that I think about it. I'm creating another condition, so if n1.next and n2.next, if n1.next is null and n2.next is null and carry is equal to 0, then break. So actually I can just rewrite this as while true. Now, yeah, and it should work. 082, is that the result? 0821. Why I'm not getting that 1? Well, I am going to the next node and I am adding their values to our sum. I am adding it to our carry. So am I resetting the carry in a wrong way? If sum is less than 10, so if sum is less than 10, so it means if it's 9, 8, 7, right, then do that. Or do I need this condition really? So if we get the modula or divide, like let's say 9 is 9 divided by 10, right? 9 modula 10 would give us a remainder of 9. No, we don't really need this condition. Yeah. How about now? Yeah, we didn't need that condition, but we still have to figure out where the problem is. Maybe I'll move all the logic for carry next to each other. So we will create a next node pretty much every time and put the sum inside of that. And we go to the next node at the end of each iteration. So at the last run here, or here, the sum is 2. We're assigning it to result. So we basically ran this line, right? So we assign, so we were actually, let's see. Yeah, we read the data. Our sum was, our result node was still pointing here. So we did the sum here and we added it here, right? And then we changed the result. We moved it from here to here. And then we basically saw that node 1 does exist, and one.next does exist. So we went to the next node, its last node, and we didn't go through the next node for n2. And for this one, did this evaluate to true? So while every single one of these is true, like if every single one of these is true, then get out of the function. So n1.next. Oh, okay. Oh, okay. So we are checking this after we go to their next node. We don't want to do that. We want to check this before we go to the next node. So yeah, let's see. Oh no. Why am I getting 3 here? That's weird. 4, 6, 10. How was I able to produce that result in the first place? So where does that 3 come from? That 3. So let's print out the value of sum here. For the last run, it's 3. Interesting. So it is 0 here. Where did it turn to 3? Oh, okay. Okay. Interesting. So we are adding this 2 with this 1. Okay. So we are not actually going to the next node, which is null there. So what should we actually do if the next node is null? So if the next node is ever found to be null, you don't want to raise an error by going to it. Let's just go to the so I would probably want to set the value of either. The problem is that if I set the value to 0, then I'm basically changing the linked list itself, our input. Very interesting. So alright, so what should I do then? Am I able to get rid of these conditions here? No? So I have to make sure that I don't go to a node which is 0. Yeah, so maybe these should be the default behavior.
It's 3 o'clock.
Right, these should be the default behavior, and then we should yeah, I don't want to change the value of our input linked lists. If I change it to anything else and assume anything else for their values inside our function, it would alter the input linked list. Oh God. What can I do at this point? Um, hmm, what I really want to do is to set the value of n1 for the next iteration to 0 if their next node is 0, right? But like, look, if I do this, if I say that this is the default behavior, sort of, or let's just say this, if that then if the next node is null, then set n1 to 0, or n1.data, and then do the same thing for this one. This would probably fix the problem, like this, see? But I think if I now try to print out these two linked lists, I basically altered them. See? I basically changed the way they were. So I don't want to fix them like that. Um, like the only way that comes to my mind is to compare the value of their addresses with and store the value of their previous addresses and see whether we are going through a repetitive node, and if we are, then ignore this block over here. I think at this point it doesn't matter if I have this condition, right? Whether I have it or not, it will automatically do the thing it wants to do. Yeah. Neither n1 or n2 are ever null. What happens if I say create new linked list nodes? If I say, like, I don't know, num1 and or num1 which is assigned to n1, create another node num2 and assign it to n2. What happens if I do that and then use num1 and num2 instead of these? Num2. And then in this place here, put else. So now I can say num1 dot data is 0. I think this won't change anything, but it worth a try. So let's do that and run it again. So it solves that problem, but does it also solve the problem with changing the address of the linked list or changing the value of the linked list? No. So since this is an object, we don't have that option as well. Unless we no, I can't come up with any good way to get around this issue. I'm still thinking. I haven't given up, but I'm having a hard time coming up with a solution here. What else? Well, I can refactor the code even more. I can say assign result.data to sum, and I don't need this else block anymore. I can just say this and not do that. This. Okay. But after this break statement, right? Because then I'll know that there are next nodes after it. If I run this again, we're still getting that false result. Now, how can I get rid of this error? So it's all good, but you're having serious issues with our last node, the way we calculate our last node. Yeah, I can't figure out any other way than to keep a reference of the nodes while doing an addition. So yeah, let's do that. Let's do our brute force. But if you have any better solutions, please let me know down in the comment sections down below. All right, so this would be our N1 prev. Okay, and it is currently assigned to N1, and this will be our N2 prev, and it's assigned to N2. Okay, and so for the first run, it's doing that. Okay, and so it's doing that, and if N1 prev was equal to N1 or was not equal to N1, so or let's write it this way, if the current one was not the previous one, then do this. And if here as well, if the previous one wasn't the current one, then do this. And here, if the previous one was the same as... wow, this would make the code so much more complex. I'm sure there has to be a better way to do this, but yeah, I can't come up with anything else, and I want to finish this problem as soon as possible. So if these are equal, if the references are the same, then go to the next node in prev. So what happens at the last iteration? The prev stays the same. Like if they are equal and in one prev dot next is not null, right? Wow. And do the same things for n2 prev, but now another issue arises, and that is for the first iteration, n1 and n2 the prev are equal to each other. And how can we solve that? We can basically... we can... what can we do? I don't want to rewrite that integer again. How does it work now? It would probably not add up the first digit. And it's not even fixing the last digit. Great. I don't want to do this. The other way to do this is that we can count the number of times n1.next or n2.next is null, and if it encountered no more than one times, then we will not read its value. This is probably easier. So byte I or byte, yeah, let's do I and j, why not? And byte j is 0, and then we'll only do this if I is less than 1, so basically 0. So if we encounter null even one time, like if we reach null, then we won't do this. And if j is less than 1, right? And if n1.next ever becomes null, okay, so I'm going to put this condition here. After we iterate, if n1.next is null, then add 1 to the I. Let's do this. Okay. No, let's not do that. And if n2 that next is null, then add 1 to the j. I'm still not sure whether I want these to be here. Before. Yeah. Yeah, let's do this. This solved the issue. This is a hacky solution to the problem, and I'm sure there is better ways to do this. So maybe I can declare these in a single line. Am I allowed to do that in Java? I am not. Cool. So, alright, that worked for this set of numbers. So now let's elaborate and make it harder. So node 8, and let's create that node 8. So I'm going to basically copy and paste one of these and make this node 8. And let's make all the digits to be 9. And oops. And here as well. Right, so we have this. Now let's print out the result of this. So this should return what? 4 nines plus, or sorry, 5 nines. 1, 2, 3, 4, 5 plus 3 nines. 100,998. So let's see if we get that result here. Where's our console? Oops. 100,998. So yeah, we basically solved the problem. So, and it's still of the longer linked list, but we had to declare some extra variables here, and we had a lot of conditional statements there. So maybe there is a better way to do this, a more cleaner way to do this, and maybe there is a way to improve this kind of logic that I use inside this solution. So if you have any comments, any suggestions, I welcome all of those, and please leave me a comment. And if you like what you see, like the video and subscribe for more coding challenges. See you later.